In this lesson, we're going to introduce solving equations, and this is going to be strictly what are called one-step equations. A lot of these equations you can actually solve in your head. You will not need to actually do the steps out in order to solve them. But that's good because this gives us a chance to practice the steps and rehearse the reasoning behind the steps before the steps get too complicated, while you can still see what the answer is. So the first thing we need to establish before we go into solving equations is review what an equation is. So an equation has an equal sign in it, okay? And what that means is that the left side has equal value to the right side. A lot of times in algebra, this is depicted by a little balance scale. Okay, you can picture like a little seesaw or a little balance where the left side and the right side balance each other out. And it's super, super, super important. It's important that you know that you're dealing with an equation and not an expression. And it's important that you pay attention to where that equal sign is. That equal sign should never drop out of your problem solving. It should never move to like another location in the problem. It's really, really, really important. In fact, it's so important that I'm going to go ahead, I'm going to just read all that in there, okay, to draw your attention to it. We sometimes call the golden rule of math. Whatever you do to one side of the equation, you have to do to the other side in order to keep it balanced. So for example, if I had, say, 3 dots on one side and 3 dots on the other side, okay, these would balance each other out. Now suppose I take away 2 dots from the left side. Well, now it's no longer balanced. Now my scale would like tilt in this direction. So I have to make sure that if I take 2 dots from the left side, that I also take 2 dots from the right side. That keeps it balanced. So golden rule of math or of algebra, okay. The golden rule is do unto others what you would have them do unto you from the Bible. Like that's what most people think of when they think of the golden rule. Golden rule, not rules, we only have one. In math is do to one side what you do to the other. And to do to the other side. And in order to do that, again, you need to be really aware of where that equal sign is. A common mistake I see happening in Algebra 2 is students not paying attention to where the equal sign is. And so they end up actually, instead of doing like taking away 2 from the left and taking away 2 from the right, they'll actually take away 2 from the left twice and not from the right at all because they're not paying attention to where that equal sign is. So let's go ahead and start looking at some problems. So there's we're going to go through 5 different like variations of things that you might see. Okay, I had to respond to a text message, so now I don't know where I was. Oh, crud. All right. I know we're going to go through like 5 different variations of things that you could see. So let's take a look at the first one. If you have x minus 3 equals 5. So again, notice where that equal sign is, okay? Now, we want to solve it. To solve it means find the value for x that will make it true. So remember several lessons ago now, we talked about what the solution to equation was. It was the value of x or values of x that you could plug into an equation and the equation would be true. So that's what we're looking for. So in order to figure out that value for x, like what we want to have is x equals and then some kind of number. So what we do is we look at what's being done to the x. Well, what's being done to the x is we are subtracting 3. Now, I'm going to try to move away from the whole plus and negative thing. I'll do it once in a while, like when I think that it's useful for the concept, but I'm going to try to move away from that because most people don't write plus negative all the time. You are free to do it anytime you feel like it will help you to kind of re-image that subtraction in a different way. But to undo subtraction, we would add. Okay, so I want you to stop and think about that. Even though I know that you can figure out the answer to this problem in your head, I want you to think about the reasoning there. If you have like $10 and you take away $3 and then you add $3, that would leave you back with the $10. Subtracting 3 and adding 3 undo each other. So I can't just add 3 to the left. Let's go back to that little balance scale. You cannot just go, oh, I'll add 3 to the left-hand side. In order to keep it balanced, you have to go and add 3 to the right-hand side as well. Over on the left, -3 plus 3 or -3 plus 3 is equal to 0. And then 5 plus 3 is 8, and then of course x plus 0 is just x. Now most of the time we skip that. We do not bother to write plus 0 because it's self-evident that it's plus 0. But one of the things that I see that's a real issue in Algebra 2 is not understanding why something cancels. Students just write, oh, these cancel, and I want it to be really, really clear that the reason the 3's cancel is because -3 plus 3 is equal to 0. Now, another way of writing that you might be more familiar with is like a vertical structure. So rather than putting plus 3 and plus 3 in line, you will often see people write the plus 3 underneath, okay? And it's a little bit of a space saver, and because normally we add numbers vertically, it tends to be a more comfortable way to look at it. -3 plus 3, of course, is that 0, and then 5 plus 3 is the 8. I tend to do both. I was taught this way on the left, but I currently teach it the way on the right. So I'll do both of them. All right, next one is suppose you have x plus 6 and that's equal to 10. So again, you can probably figure out x is going to be equal to 4. And I get that. Like, hopefully you can do that in your head. But we want to practice the algebraic reasoning. So if you add 6, the way that you would undo adding 6 is you would subtract 6. So add 6 and then subtract 6, that's going to give you that 0. It's going to bring you back to the x. But you can't just go and subtract 6 from the left. That means it's not balanced. So if you're going to put a -6 on the left, you've got to go and put a -6 on the right. 10 minus 6 is 4, so of course x is equal to 4. Vertical structure on that would look something like this. X plus 6 equals 10, and then people will write the -6 underneath. 6 minus 6 is 0, leaving you with just the x, and x is equal to 4. All right, next version of this that you might see would be x divided by 2 is equal to 3. Now again, if you think through this, like what divided by 2 gives you 3? 6 divided by 2 equals 3. Like I get that you can figure it out in your head, but we want to practice that reasoning. So this is division. This is x divided by 2. So you want to think, okay, how do we undo division? Well, if you divide something by 2, you could undo it by multiplying by 2. So that's supposed to be times, guys. Sorry about that. So x divided by 2 times 2 would leave you back with the x. Other people might do this. They might look at the 2 over 2 and say 2 over 2 is 1. And so you've got 1x. Now you cannot just multiply the left side. Whatever you do to the left, you have to do to the right. 3 times 2 is 6, and of course 1 times anything is the anything, leaving you with the 6. And the reason I want to emphasize that is, again, a lot of my students in Algebra 2 will just say something cancels, but if you ask them, like, why does that cancel? They wouldn't be able to answer. So it cancels because a number divided by itself is 1. Next one, 4x equals 12. So remember that that is multiplication, that's 4 times x, and you always want to kick back to, okay, what is happening to the x here? So in this case, what's happening to the x is multiplication, and then you think, okay, how do we undo multiplication? It's called the inverse operation is what we're looking for. Well, that would be division. So I'm going to go ahead and divide by 4. 4 divided by 4 is equal to 1. But you can't just divide the left side, you have to go and divide the right side. And 12 divided by 4 is 3, and of course 1 times x is just x. Now most of the time, just like with the 0 in the other problems, we do not write the 1. I am just doing it to emphasize why the numbers cancel out. It's not like magic. If you just do this like little thing, like you can make your numbers disappear. The reason it cancels out is because 4 divided by 4 is 1 and 1 times x is x. The last concept here is just this. If you have x equals 7, that is the same as 7 equals x. That is actually something called the symmetric property, which you might encounter in geometry. And it just means that whatever side of the equal sign you're on, you can always just switch the two sides. Some people always like to have the x on the left-hand side. Some people don't care. I tend not to care. All right, so let's go through just a few more examples. So if you have x minus 5 equals negative 13, this one's a little bit more challenging because of the negatives in there. So it's a little bit harder to figure out, okay, on that number line, which direction are you going? And of course, equations get much, much more difficult. So we want to practice the basic skills. So we look at the x. What is happening to the x? Subtraction. How do we undo subtraction? Well, we add. And so if I subtract 5, I can undo that by adding 5. But I can't add 5 just to one side of the equation. I have to add 5 to the other side. Golden rule. Over here, negative 5 plus 5 is 0. And then over on the right, you might want to bust out your number line. Okay, so you start at 0, we're going to go negative 13 to the left, and then we're going to back up in the positive direction 5, which is going to leave us at negative 8. And of course, then x is equal to negative 8. Most people doing a problem like this would do this. They would add the 5 vertically. They would not say negative 5 plus 5 equals 0 because it's understood that it is. And then they would simply just write x equals negative 8. And of course, a lot of people will do that in their heads. But don't jip yourself in this lesson of the practice of making yourself go through the steps. Here's another good one. Okay, this one has the variable on the right-hand side, but math is awesomely consistent, so the process isn't going to change. What's happening to the n? We're adding 4. How do I undo adding 4? I subtract 4, because 4 minus 4 is 0, and we'll leave the n by itself. But you cannot just subtract 4 from one side. You have to subtract 4 from the other side in order to keep it balanced. 4 minus 4 is 0, leaving me with n. And then this might be better to do with that little plus and negative. So instead of thinking of negative 8 minus 4, think negative 8 plus negative 4. So you're going to go 8 to the left and then another 4 to the left, which means that all told, you're going to be going 12 to the left. You might write it as n equals negative 12. All right, next one. 4x is equal to 128. Same thought process. And this one, like the number is big enough so that you probably can't just do that one in your head. You do need to figure out what the operation is and then carry it out. So we have 4 times x. We think to ourselves, okay, how do I undo multiplication? I undo multiplication with division. 4 divided by 4 is 1. Please don't lose sight of that. Okay, so it's 1x. 128 divided by 4 is 32, and of course 1 times x is just x, so x is equal to 32. Okay, let's do a couple that involve some fractions, okay, just so we can see how those go. So suppose you had 1/5 times x is equal to 30. There's actually a bunch of different ways you can think this one through. The most direct way is to multiply by the reciprocal. If you have 1/5 times 5 over 1, which is of course the reciprocal, that's 5 over 5, which is 1. So I can take the left side and multiply it by 5. And then I have to make sure I do the same to the right side. Now I already did my scratch workout. So 5 times 1/5 is 1. And 30 times 5 is 150. And of course 1x times 1, or 1 times x is just x. Okay? Some students will miss that. They'll miss it. So they'll say, okay, 1/5 x is equal to 30. This is multiplication. And they'll say, all right, well, I'm going to go divide by 1/5. 1/5 over itself is equal to 1, because anything divided by itself is 1, which is the 1x from up here. Okay? And then you need to bust out what we did in the division lesson and say, all right, 30 divided by 1/5. Division is multiplication by the reciprocal. So that would be times 5 over, I don't know why I did that, 5 over 1, which is 150. And it also works. Okay, so whatever way you want to go with it, like math, I keep saying math is really consistent. And so the principles that govern it don't change. If you've got the skills in place with the numbers, you can attack a problem several different ways. Last one, let's look at -2/3 m is equal to 10. So you can do this the same way. You can multiply by the reciprocal. If you do -2/3 times 3 over -2, that would give me -6 over -6, and anything divided by itself is 1. So we'll do 3 over -2, and whatever I do to one side, I must do to the other. So we already did the scratch workout here, so that gives us 1m, and then let me set my scratch work off. So we're going to do 10 times 3 over -2. That would be 10 times 3 is 30 over -2. 30 divided by 2 would be 15. And a positive divided by a negative gives you a negative. So that would be -15. You could also approach that one by dividing both sides by -2/3, and that would also work. So that's your one-step transformations or one-step equations is also called one transformation equations. So as always, I'm going to put some examples onto the next slide for you to practice on. Here we go. 4 plus t equals 13. W minus 5 equals 11. The absolute value of -3 plus n equals 0. X minus -3 equals 4. 10x equals 100. 15b equals 5. 1/3 x equals 78. -3 over 4l equals 75. X over 4, or x divided by 4, equals 2. And m over -4 equals -3/4. Pause the video, work these out on a separate piece of paper, and then unpause it so we can go over them. All right, so for this first one, we have 4 plus t is equal to 13. So remember that this is addition, this is commutative, so if you're more comfortable, you can think of that as t plus 4 equals 13, and then you can structure this either horizontally or vertically, but we undo adding with subtracting. 4 minus 4 is 0, and then 13 minus 4 is 9. So that's the first one. This second one, just for variety, I'm going to go ahead and structure it differently so you can get comfortable with the different ways that people write them. So instead of doing this horizontally, I'll do this vertically. We undo subtraction with addition. So instead of writing like the +5 here and the +5 here, what I do is I'm going to write the +5 underneath, bring down the W, and then -5 plus 5 is 0, which is why it cancels out, and 11 plus 5 is 16. And then the third one, we don't want to forget our absolute value. The absolute value of -3 plus n equals 0. We also don't want to be freaked out by zeros. Zeros are awesome. The absolute value of -3 is 3. And then we want to try to grow in our problem solving. So in number 1, I went and switched the order of it in order to make it easier to see what to do, but we don't want to be doing extra steps if we don't need to. So if you recognize that this is a +3 that is being added on, then the way that you would undo that is by subtracting 3. 3 minus 3 is 0, leaving you with n, and then 0 minus 3 is -3. You do not have to show your work identical to like the way that I'm doing it, but you should be showing what that process is. Next one, x minus -3. So this is where it is good to remember that definition of subtraction. Subtraction means adding the opposite. So to add the opposite there, the opposite of -3 is 3. This is problem 4. And now I would undo adding 3 by subtracting 3. Now, never, ever, ever lose sight of why those 3's are canceling out and going away. They're not just going away. They are going away because 3 minus 3 is 0. And 4 minus 3 is 1, and then x plus 0 is just x. Most of the time, you will not see me or any other teacher write that 0 in there, but it is there, okay? It's just, yeah, it is there. In contrast to the one in number 5, okay, this is multiplication, and so we think, whoops, how do we undo multiplication? Well, we undo multiplication with division. So we're doing 10 times x, and then we're dividing by x, or dividing by 10. Now here, you'll see them also canceling out, but they cancel out for a different reason. 10 divided by 10 is 1, giving you 1x. 100 divided by 10 is 10, and then 1 times x is just x. So some of the problems you end up with things canceling out to a 0. If it's adding or subtracting, you're going to cancel out to a 0, and that's why they're gone. And then if it's multiplying or dividing, it's probably because they're equal to 1, and then 1 times x will give you just the x. This next one, number 6, we have 15b equals 5. Remember, that is multiplication, so we undo multiplication with division. 15 over 15 is 1. And then here, we probably would like to simplify that fraction. You know, you want to be sensitive to the directions, but 15 over 5, 5 divided by 5 is 1, and then 15 divided by 5 is 3. So that one simplifies to 1/3. If you got the 15 over 5 and you just didn't notice or think to simplify it, go ahead and make that correction now. The next one, number 7, this one is one that I'm going to do with the reciprocal because it is the best way to do the problem is with the reciprocal. You can do it with division, but the reciprocal of 1/3 is 3 over 1, and whatever you do to one side, you have to do to the other side. 3 over 1 times 1 over 3 is 3 over 3, which is 1. And then 75 times 3 is 225, I believe. 75, 150, yeah, 225. Okay, same deal with number 8. Okay, I'm going to do this with multiplying by the reciprocal because that's the best way to envision it. So we're going to multiply by the reciprocal, which would be 4 over -3. This is negative 12 over negative 12. Anything divided by itself is 1. And then over here, it's actually easier to do the division first, because you could do 75 times 4 and then take that answer and divide that by 3 or negative 3. It's actually easier to do the division first, which we know we can do because of like the order of operations. Multiplication and division have the same rank in the order of operations. So 75 divided by 3 is 25, and then 25 times 4 is 100. And of course, it's negative because of that negative thrown in there. Last two problems. Number 9, x divided by 4 is equal to 2. Well, how do we undo division? We undo division with multiplication. Whatever you do to the left, you do to the right. If you have x divided by 4 and then multiply it by 4, you will be left back at your x. 2 times 4 is 8. And you should be able to confirm that. 8 divided by 4 is equal to 2. So like it's good with the simple problems to get that to confirm. Now this last one I thought was interesting. If you solve this last one using like just the operations, so we have like negative 3/4, and then you realize, okay, well this is dividing by negative 4, so I undo that by multiplying by negative 4, okay? M divided by negative 4 times negative 4, or negative 4 over negative 4 is 1, okay? Leaving you with the M. And then on the right, a negative times a negative gives us a positive, so negative 3 times negative 4 is positive 12, and then 12 divided by 4 is 3. Now there is another way that you could reason this one out. So I'm going to hop over here. The negative in front of the 3/4 can be put like in front of the fraction in the numerator or in the denominator. And I think I went over that in an earlier lesson. But what I'm doing in these videos and what I'm doing in my classroom, I'm not always keeping them straight. But you can. And if you don't believe me, you can bust out your calculator. Okay, now what that does is it visually makes it apparent that you've got like something divided by negative 4 equals something divided by negative 4. And if you're just dividing both sides by negative 4, or the denominators of the fractions are the same, then it is reasonable to conclude that the numerators would have to be the same, because that's how fractions work. So if the denominators are the same, and they're equal fractions, then the numerators must be the same. Therefore, m would have to equal 3. So I wanted to include that one just because there are sometimes some like slick ways that you can reason it out. I know this video is running long, and that's because the concept is important. Please, 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 please resist the temptation to do these in your head and make yourself work through the algebraic thinking that goes into solving it, because our next lesson is going to be multi-step equations where there's multiple steps to do and you won't be able to do them in your head. So you need to practice the reasoning before we get to that point. So I will see you all in the next lesson.